All right, so in this short video, we'll take a look at equivalents. Equivalents, which is a short section in chapter 9. So the first thing that we want to consider is what exactly is an equivalent. And it's defined in your textbook as the amount of that ion, whatever ion that is, whether it's sodium or chloride or potassium or calcium, that's equal to 1 mole of positive or negative electrical charge. All right, so if you have 1 mole of sodium ions, for instance, or 1 mole of chloride ions, they are each equal to 1 equivalent because they contain 1 mole of charge. If you have an ion with a 2 plus charge or a 2 minus charge, that would then suggest that there are 2 equivalents for each mole of that ion, right? So again, the equivalent is the amount of that ion that's equal to 1 mole of positive or negative electrical charge. So if you look down here in your table, all right, so it shows that if you have something like iron 3 plus, all right, with a 3 plus charge, that actually has 3 equivalents in every mole, 3 equivalents of positive charge, in other words. If you have something like sodium with a 1 plus charge, it will only have 1 equivalent. Similarly, if you have something like carbonate with a 2 minus charge, well, then there are actually 2 equivalents of negative charge in it, right? So the magnitude of the charge then tells you how many equivalents you have for that 1 mole of that particular ion. So this equivalent and milliequivalent that we'll see in a second is just another unit of concentration that's used quite frequently in healthcare settings, right? So just to recap really quickly, if you have 1 mole of sodium ions, then you have 1 equivalent of positive charge. If you have 1 mole of calcium 2 plus, well, then you actually have 2 equivalents of positive charge. If you have 1 mole of aluminum ions, then these have a plus 3 charge. Well, then that will mean that you have 3 equivalents of positive charge. All right, so that's how we make sense of the charges on the ions and the equivalents that they're equal to. And the way that this relates to milliequivalents is actually just a regular metric relationship. All right, so 1 equivalent then would be equal to how many milli equivalent? Well, milli means 1/1000th of something, right? So if you have 1 equivalent, then you would have 1,000 milli equivalent. That's the same thing as saying, for instance, 1 liter is equal to 1,000 milliliters, right? Same exact idea. We're just using the metric prefix milli here to represent that size. So let's take a look at how we can apply this to an example problem. Right, so we looked at equivalents, and then when we look at the number of equivalents per liter, for instance, that would be a unit of concentration. So let's say, for instance, that the concentration of chloride ions, let's say Cl minus, is 0.51 grams per deciliter dl, and we want to know what this is in and we're going to convert the units now to milli equivalents per liter. All right, so we're given, just like we would in any question, we want to write down what we're given. So we're given 0.51 grams of the Cl minus per deciliter. And we need to eventually convert that to milli equivalent per liter. All right, so you'll see here that this is actually made up of 2 conversions. We want to go from deciliter to liters, which is just a metric conversion. And then the new thing here is you want to go from grams of the chloride to milli equivalent of that particular ion. All right, so in order to get from grams to milli equivalent, we have to first of all get to equivalent. In order to get to the equivalent, we actually need to get to moles because that's our link between those two. So the way that we can set this up, all right, is if we have, we're going to start with our 0.51 grams of the Cl minus per deciliter, and let's do the grams to the milli equivalent first. All right, we first of all want to get to moles. So for every 1 mole of Cl minus, 1 mole of chloride, we look it up on the table. We have 35.45 grams. Okay, so the grams go away. And now, based on the new thing that we just learned, for every 1 mole of Cl minus, right, because it's got a -1 charge, we have 1 equivalent of that negative charge, right? So again here, the 1 would be what we use. And to get to from equivalent to milli equivalent, that's a metric relationship, right? So for every 1 equivalent, we have 1,000 milli equivalents. So equivalent goes away. So right now we have our milli equivalent unit on top, which is great. And then to go from deciliter to liter, we'll do that one in a different color, maybe. So to go from deciliter to liter now, right? Deci meaning 1/10. So we have 10 deciliters for every liter. So then the deci can cancel all the way over on this side. So when we look at our units, all right, we see that we end up with the only unit on top being milli equivalent, the only unit left on the bottom being liters. So that makes sense. When we evaluate this, our units are going to be milli equivalent per liter. We just plug it into our calculator. All right, and we get whatever that ends up being over here. All right, so that's how we go from, in this case, grams per deciliter to milli equivalents per liter. So we're using a couple of relationships we've used before. We want to get to moles. We use the molar mass of Cl. And then the new thing is how that mole, 1 mole of an ion, how that relates to an equivalent of either negative or positive charge. Okay, so let's take a look at another example. Let's say that a solution has 100 and let's say 56 milli equivalents per liter each of Na plus and Cl minus. So it's got sodium ion in it, it's got the chloride ion in it, and what we need to figure out is how many moles of sodium ions, Na plus, is present in let's say 2.50 liters of this solution. All right, so again, you want to list what we're given. So we're given in this case the concentration in milli equivalents. We have 156 milli equivalent per liter, and what we're concerned with here is the sodium of Na plus in this solution. And then we're told that we have 2.50 liters of this solution, right? No, we don't have 1 liter, we have 2.50 liters. So we have 2.50 liters of this solution. So we can use that information to figure out the total number of milli equivalents we have in 2.50 liters, and then we can go ahead and pull in now some of that earlier stuff that we learned. All right, so what we eventually need here to get to would be moles of Na plus. All right, so let's start. We'll write down what we're given. So we have 156 milliequivalents per liter, and we don't have a liter. We have 2.50 liters of the solution. Okay, so just by multiplying that, we end up with a total number of milliequivalents of the sodium that we're dealing with. If we want to get to moles, we first of all need to get to equivalents. So to get from milliequivalents to equivalents, for every 1 EQ, we have 1,000 millieqs. So millieqs go away. And then for sodium, right, so Na plus, it has a charge of +1. Then we can write this up here as well. Okay, so this tells us that for 1 mole of Na plus, which has a +1 charge, we have 1 equivalent of positive charge. All right, so then we can say for every 1 equivalent of positive charge, we have 1 mole of Na plus. Equivalents go away, and then we end up with our mole as our unit. That makes sense. So we just go ahead and stick that into our calculator, and then we'll get our answer here at the end.